Hey, this is Steven, and welcome back to another one of my video analysis. This one hopefully way shorter than the last one. This is a school exclusive. Um, this is a reply to Scotty's video that we covered last week. Last week, basically 8 days ago. And they are, Micronics is talking about their Micron printer, and they are doing a reply to Scotty's um, e- uh, YouTube video. So go ahead and watch my previous video analysis on that. I know that video is an hour and 15, but let's go ahead and look at the reply here and see what that looks like. And we can go from there and see what we think about this. I have some tabs open there at the top with the resources. And so we can talk a little bit more about some of the things here. Let's go ahead and get started.
2 months back, we shipped a few pre-production SLS printers to a bunch of content creators to put them through their paces. Some things rocked, others...
Okay, so again, we talked about this. Basically, you have that the process here, right? So if we go here, this is generally the process that you're going to want to follow is this guy here, right? For your product development process. So first off, you have an alpha, right? And again, like I said, I'm going to add here, you can do phase like 3, 4A, phase 4B. So you can have like an open and closed alpha. So you can have a closed alpha where people are held under NDAs, right? And then you can help have them develop for you. And then you can have phase 4, phase 4B, which is a open alpha where people are not held in an NDA. And then you can go to what they're doing right now is their Kickstarter, which is a phase 5 beta. Or if you want to have even less problems with that one, you can even push that off to a phase 6 release and push everything out. So you can do, Kickstarter here at the phase 6. You can do a Kickstarter here at the phase 5. Um, and also, if you do a Kickstarter phase 6, you could even do phase 4A, phase 4B, open closed alpha. First closed and open alpha, and then you can do a beta and then release in Kickstarter. And then you can get to the YouTubers. But it is not suggested to send to somebody you do not know or somebody that is not being paid to help develop your product for a phase for basically an open alpha or an open beta, especially somebody that has a viewership like Scotty. So actually, after that video aired, I looked at more of his stuff, and I'm actually more familiar with his main channel. I forget what it's called, but I've watched it multiple times, and I watched about like his brain injury and things like that have happened to him. So this other one's his second channel, and so I'm more familiar with his main channel. So he has a pretty decent following. The channel that we watch is a smaller following, but still he's got a decent sized following in general. So why do that for a basically skip the alpha state and go directly to a very, very open beta, right? Or even go directly, in this case, to a open alpha. There's no NDA in place, and you're in a really rough shape. Because basically, to me, it seems like they shipped a prototype and kind of got burned from some of these issues because there was just not enough development. And I could talk a little bit about, in my current day job, this is basically what happened to us. Because of the rush of getting a product to a customer, we shipped it early. And when they got to the customer, we now have constant issues with safety problems, integration problems, BTP part issues, built to print parts not being made to the print, and just continuous issues in front of the customer and one of our biggest customers, right? And so that is not great to ship a prototype. Even though they are familiar that it is a prototype, they expect it to be further along than it is. And sometimes you have to be, in this case, the customer isn't always right. I mean, sometimes you have to be the person that applies logic here. because you're gonna get shot in the foot both ways. So okay, the customer's asking for it, customer asking for it. Okay, in this case, let's say you don't have one big customer, you have a lot of small customers. So in that case, it's the market. Okay, the market needs this product. If I push it further back, I'm gonna miss some sort of inflection point in the market. Or if and then maybe it doesn't have as much of an impact as it did, or the customer's asking for it, but you ship it early and it's too early and you have problems, right? So either way, you kind of screw yourself, right? You try, okay, push, 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 push. Oh, here, customers ask for it, just send it. And you send it and it doesn't work, right? Especially when you have your company has other products that this customer buys. Let's say if it's an individual customer, or this is the first, or your company is new and this is your first, in this case for Micronics, and this is your first product, your first foray into the market, and you need to have a good impression. Set a good impression, right? If you need to tell the customer, hey, you have to wait, that is what it is, right?
Not so much. So today we're diving into what we are going to change to make them better. Stick around to the end of the video because we've got some exciting stretch goals and of course, thoughts on Scotty's feedback. Oh, and by the way, it was absolutely awesome meeting so many of you at OpenSauce last week. First, I think it would be helpful to look at the performance of the machine objectively. We are not trying to
So like this is good. Open Sauce, right? Open Sauce is a show in California. I didn't go this year. I wasn't aware of it. I was aware after the tickets were very expensive, but I will make sure that I attend next year. But that's a great place to go and show off your product, right? For like that prototype stage, right? So you can go there. That's where this makes sense. Okay, show the prototype. Does it look good? Okay, does it make a good first impression on the outside? Does the assembly look good when removing it? So that would also be most likely you can't get somebody to do an NDA at a public, well, semi-public. Obviously, people are paying tickets, but you can't just say, "Hey, tell the person who's putting on the show, I'm going to require an NDA of anybody that is within eyes distance of my booth." You can't do that. So that would be another time that you can do, like maybe even you have a closed alpha where people are helping you develop it, and then that could be your open alpha, okay, talking about it, showing it, or even in a beta phase. So you can do that, but mainly is to have people get your hands on it and find issues. So but you can do something like that, like a show in um, any of these three stages: prototype, alpha, or beta, or and again closed or open alpha, and be able to show something. But again, we want to have it polished. First impressions are everything, right? Now you can no, they're not the end all be all. Like you can recover, but yeah.
downplay the things that didn't work.
Okay, so here's kind of this is their deliverables. This is their timeline for their projects. So this is kind of like the quote unquote, as my manager's manager talks about it, the laundry list. So this is kind of their laundry list of things to do and clear out. So this is kind of what we're talking about here. And this would definitely have been more professional format. Now, having everything on one side and still seeing the founder on the other side, I guess that kind of helps. But and they have everything color coded, which you see here, also everything color coded, right? And so this would have been a way more professional way of showing it. But this is one of the other ones that I showed here, which we go to. So this is kind of my style one of that. So here it won't get too long because you have it go left and right, so it stays very tight and very focused. And this is more of like a day to day, so you could do something like this. The problem why you generally do this type of Gantt chart is you kind of see how things stack up. So on this, you can't really tell how things stack up. Like, okay, is something driven by something else, right? And I'm guessing this is like month, 4, 5, 5, 5, something like that. I don't know if this is date, but yeah. So what you can see here, they kind of talk about their deliverables and their planning
Those
stage.
are real issues. But we also think it's too easy for the negatives to overshadow the positives. Just because.
Okay, 100% wrong here. You get credit for your machine working, not trying, right? So if you work for a company, you get paid for trying, right? And succeeding a certain amount more than failing, otherwise you get let go, right? But in your own business with your own product, you don't get rewarded for making it most of the way, halfway, 3/4, 80%. You get credit for it working, the uptime, right? And obviously Scotty struggled with the uptime. So what uptime do you want to have as a company? If it's how Scotty was, where he got through maybe a print and then he just kind of gave up on it. Again, he got it for free. So maybe if you spent $4,000 on this machine, you may give it more of a go, right? But again, it's not this world. You don't get credit as a business for your work. You get credit for your product, right?
One person had a dead on arrival printer does not automatically invalidate.
And here, so you have one person out of 3 here. So this is Applied Science. This is Alliance Tech Tips channel. I forgot. And then this is 3D Printing Nerds. So, and Scotty's the 4th person. So out of 4, 1 failed. That's 25%. It's not a great outcome. Again, if you have a failure rate, generally, I'm going to have here on the design system Famica, the failure rates here, the occurrence should be less than 2%. And even less than that. I'll provide another tab to talk about the occurrence. It should even be less than that. So you are 12 times over what your occurrence should be. So that means on your design Famica, severity is like a 10. This occurrence is like a 10, and so the severity, machine doesn't work. This is a 10. 10 times 10, that's 100. You already need a mitigation, right? Already, and if you need a mitigation, your product has a problem. Just one. The ideal is 0, right? And right now they're at multiple. Shift bin's messed up. You have problems with the spreader. You have problems with the auger. You have problems with shipping. So you have multiple here, right?
Others that have had positive experiences. 5 of the machines we have sent out have been tested so far. More videos coming soon.
So Hacksmith, which we haven't seen yet. Big fan of those guys, which maybe we'll have to watch those as well. But yeah, so you sent out 5 machines, let's say. And so far, it sounds like Hacksmith is going well. So now you have what, 20% failure, right?
Which revealed that certain components, like the auger,
ideal is 2%. So you're still 10 times.
Have some issues, while others, like the powder flipper and FDM printed sift bin, need a more thorough overhaul. However, it's also crucial to highlight where we excelled. The most complex part of the entire printer, the optic system, worked without a hitch.
I mean, sure, you can talk about where it excels. You can say, oh, my product in general doesn't work very well, but when it can melt powder. Like, the thing that's really needed to do for the printer works is it can melt powder, but it's not reliable. Uptime is high. Occurrence is high on your failures. Problems, right?
From the laser source and optics to the Galvo system with its custom driver, the main board and firmware, even the printer's UI, everything operated seamlessly together. Our slicer, another intricate part of our setup developed entirely from scratch, also worked with minimal issues. And when the prints work, they're exactly as shown in our videos. And we're not hiding the fact that print failures occur. They do on ours, but that's true even on the most high-end machines. What sets us?
This is another big part. A big part also of my day job is this whole, almost like a no true. It's like almost like a no true Scotsman fallacy, but a little bit turned to like, hey, these guys have the same problem, so if I have this problem, that's okay. That's not how this works. You want to do better, then than your competitor, right? Match or be better. Saying, hey, I'm average is not a great marketing idea, right? If you go and tell your customer, hey, I have an average product, I have an average product, I have an average product. You can have you can have an average price, but you want to shoot for the high end of the you want to shoot for the high end of the performance, or even like just blow the high end performance one out of the water. So this is also another fallacy that tends to come up, and it's caused a lot of problems in my day job. And so I would suggest you want to shoot for as high as you can go, and then just like you want to under. So another issue here that happens a lot, you can see like the No Man's Sky thing that happened. You want to under promise, over deliver is the key. Under promise your performance, and then over deliver on the performance. You want to overestimate on your deliveries, and then pull it in and deliver it in 20% of that time, etc. You want to give a price. Let's say you give $1,000, you're able to pull in at $800. That is what customers like. Is under promise, over deliver. Be realistic.
Apart is our algorithm-based print failure detection, which successfully identified and aborted 100% of problematic prints before they could wreak havoc or break the printer. Now, let's dive into the main changes we're implementing.
Again, this is the safety thing that we were talking about, where you have the warning devices. So in this case, it just a lot of their interlocks seem to be very good. Again, but that should be below the 2% occurrence, right? So another thing I want to get to is that means that basically this was never encountered during the initial testing. Is pretty much what's going on. Like, so how much testing was actually done, and was there not enough marathons completed to have this? And you have to adjust according to what is your volume. So for example, if you sell a multi-million-dollar piece of equipment, maybe you don't have to test 15 of it, because maybe you don't target to sell. Maybe that's like 4 years of your sales, right? And maybe I'll come up with a number and look at some BCAM's best known methods in different markets to look at what an average would be of how many units you should test until you know, hey, this is a decent sample size of what I will have in the market. So for example, if you sell like $1 million piece of equipment and you sell 10 a year, maybe 3 is good enough. 3 is a third of what you would ever sell. So for example, on his Kickstarter, he's selling like 100. And if he tests 10, then that's 10%. So, and then you send another 5, and one out of the 5 fails. That's a problem, right? So maybe a sample size is just not big enough of how much he actually intends to go into the market. And then when you have your next beta unit, after you've gone to, or once you have your full production unit after the Kickstarter, that will be what you intend to sell in a couple of years. And you can have that, right? Run marathons with it, right?
Starting with the auger. Basically, it all comes down to clearance. Early on, we had issues with powder leaking back down the...
This looks like a very, very cheap built-to-print part. It's not even outside surfaced. Like, how's your tolerances here? I guess it doesn't matter. It depends on your clamping. It's also your machining here. Looks very, very rough, right? I don't know if they made this one in-house. We have a lot of chatter here, right? And this surface step over finish is not very good. So it looks like this was maybe done on a mill with a 4th axis.
Down to clearance. Early on, we had issues with powder leaking back down the auger when the auger wasn't rotating. Our first thought, the clearance between the auger and the tube was too generous, leading to this leakage. By tightening this gap, we managed to solve the problem somewhat, which led us to move on, thinking it's solved. However, we later uncovered the true culprit, which is the auger's inlet was too restrictive.
Okay, so basically it's kind of like CIP development. So you had a problem, you integrated a solution. What's your transparency? Okay, go ahead. You changed. You think that you solved the problem. Okay, where's your marathons? Where's your testing? Okay, the problem's solved. We've locked in. We've integrated this into the BOM and the model, and we're good to go. Right? Transparency is identical. What's your performance difference? Did it change your reliability? All these things.
This caused the powder to be lifted faster than it could be replenished. After addressing this, we kept the original auger configuration as it performed well in our tests. Nonetheless, we didn't foresee how shipping impacts could affect the printer, and indeed,
So I can't really tell what he meant by that before. Like, you reverted back to the original design that jammed. That's basically what it sounds like. So it sounds like both versions didn't work well. So it sounds like what he did is he went back to the original design that had tight tolerances and opened the inlet hole. And then it sounds like now it's kind of weird because in Scotty's video it sounded like it got jammed, not that it was an inlet problem, right? So now that jam is going to happen again. So he didn't discuss here, I guess, the fix. He discussed how we ended back on that same issue, right? Is that, hey, we fixed the problem and then we actually thought it was a different, and then we fixed that problem and it stopped jamming, but then we didn't get a powder solution, didn't get the powder in, which is a different problem. And then we said, oh, that may be the initial problem. So we reverted back our first fix and did the other fix to open the inlet hole, and now we're jamming again. But we're getting good powder feed, but then it just jams and stops working.
one of the 5 machines experienced an auger jam. To fix this, we simply need to increase the clearance.
Again, 1 of 5 is not good. 2% or less.
Additionally, we've modified the control board to allow the motor to reverse for minor jams. While tapping the auger with a hammer might...
So that's another mitigation. So that's a design mitigation. Okay, we can back it up. We've done a design change. There's your design and system FAMICA. Okay, the occurrence was way too much. 1 out of 5, 20% failure. Occurrence is 100%. Occurrence is 10. Detectability, kind of hard to tell what exactly is going on, but luckily their software will tell you, hey, there's a jam. How to fix it? Not quite sure. Severity 10. 10. This is like maybe a 2. So you're talking about 100, 200. Okay, way over 100. Let's do mitigation. What's the mitigation? Fix the issues to make it not jam, and then add a software mitigation that if it starts to jam, it tries to recover. Okay, there you go. What is your post mitigation severity, your post mitigation occurrence, post mitigation detectability? So you need to do your marathons again. Figure this out. Work with your closed alpha testers, etc.
It seems silly, it did resolve lighter jams. As the saying goes, always start with the simplest solution. Let's move on to the powder flipper, a critical component that has given us...
Smacking your motor with a hammer is not a solution. It working when you give it to the customer is a solution.
Quite a bit of headache. Here's how it works. The auger lifts powder, which is then evenly spread across the width of the build area by the flipper's rotation before being lifted to the build surface. When we first noticed recoat failures, our gut reaction was to blame the gear driving the powder flipper, thinking it was skipping. But digging deeper, we uncovered a sneakier issue. During longer print jobs, some powder particles were getting in between the shaft and the bushings, causing the flipper to bind and fail.
So basically he's saying that this is a bushing here that allows this wear surface. So it's the oil impregnated bushing, right? And allows this shaft of the flipper to rotate on this, right? And then they're basically saying the powder, this very fine powder that gets basically everywhere, was getting inside here and jamming this guy up and causing failure. And you can see all these wear marks here of where it's rubbing with the powder against the wall, and then all the wear marks here on the front of the bushing.
To lift the powder. This led to...
Again, what's the call out of this? What's the call out of this surface here? Is it 16RA or smoother? You get a good dynamic wear surface. How is all this going, right?
Powder. This led to the printer detecting a recoat fault and stopping the print.
Also, was tolerance stack up done here? When that thing heats up, is it clamping down on that flipper? Did you give enough space? Did you set it up such that, hey, this thing is going to operate when it's heated. Is okay, now it's going to shrink into the tolerance that I need, right? Is the stack up done for
While it
that?
might seem like a trivial oversight, it's precisely these kinds of problems that beta testing is meant to catch.
I agree. And again, this shouldn't be beta, it should be alpha. Alpha testing should catch, or you catch it in your prototype phase. So go in here. So it should have been caught in most likely either your prototyping phase or in your closed or open alpha phase, right? And then before you get into your beta, because generally your beta is going to be like, hey, let's get this out to people to talk about it. So I get ready for a release and I don't do a cold release, right? So I don't think these things should be caught in a beta release because now they're going to release it to the world and now you get your reputation damaged and you won't be able to get that back, especially your first product.
To tackle this, we've come up with a straightforward redesign for the bushings. The new design will incorporate partial slots that are designed to let any trapped powder escape, while still keeping a full circle front face that acts as a barrier to minimize further powder ingress with.
Okay, so this is again your component flipper, possible failure modes, powder getting stuck in between the bushing, tolerance issue when expanding, surface finish, pinching. It's pinching. It's overloading the motor for some reason, and we've potential cause of failure is basically this one would be component powder flipper getting jammed. Potential causes: powder getting stuck in between the flipper, stack up of the tolerance stack up when heated. The flipper is pinched, so it jams, overloads the motor. You don't have to put overloads the motor because that's what you put in the potential failure modes. But it jams, and then now the problem. Okay, what's the effects? Printing failure. Okay, what's your controls? Okay, the controls are, sensor on the motor, and it will stop the print. Okay, what's the severity if a print is stopped? 10. The failure. Customer is going to get mad. Occurrence, 1 out of 5, 20%. Okay, so this is 10. 10. Detectability. Kind of hard to tell exactly what's happening. Is it the motor's bad? Is it the powder getting stuck in it bad? How is the customer going to fix it? Do you have to send the thing back? A lot of problems here. This is 200, 300. What's your mitigation plan? Okay, I'm going to redesign the bushing, run my marathons again, check my transparency. Okay, my occurrence now is under 2%. So let's say this is 3, 4, 5, whatever. You'll have to look at when I attach this one. Severity, low. Well, severity is still high. It's 10 if it fails. Occurrence is low. Detectability is most likely it's no longer the bushing. So now it's easier to know. If it fails, most likely it's the motor. Detectability goes up, right?
Without adding unnecessary resistance. These bushings are made with powder metallurgy, and the custom dies for them are surprisingly affordable.
Again, what's the tolerance on this?
Alright, let's address the elephant in the room, the sift bin. Yes, the structural integrity of it is absolutely terrible in its current state, and we are really sorry for everyone who has had it crack and make a mess. There are two main culprits. One is how we pack them for shipping, and the other is the walls that are too thin for their own good. In an effort to cut down on the shipping cost, we placed the heavy powder bottle inside of the bin, which, surprise, surprise, led to cracks during transport. Moreover, when you're shaking it with heavy parts inside, those parts banging against those thin walls also led to further damages. For now, we are beefing up the wall thicknesses and adding sheet metal inserts to better distribute the impact loads, and of course, shipping the powder bottles separately. We were all set to show off the improved.
Okay, so that's good. So basically, they're going to change how they're shipping, and they're going to ship the bottles separately, do an overhaul, increase wall thickness. So there you go. Here's all the design, component, shipping, cracking, or component shift bin. What's the problem? It cracking and leaking powder everywhere. Potential cause of failure mode, putting other heavy crap inside and thin walls. Thing moves around. Effects is it cracks this one and leaks powder everywhere. And if no PPE, could cause problems, health problems, blah, 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 leaking inside the house, other safety issues, right? And then what's your controls for that, And then severity, right? Severity low-ish, doesn't cause problem, it's just impact on your your business, right? People shoot videos of it and kind of talk about your product, etc.
Been in today's video, fresh off our trip from Open Sauce. But as luck would have it, our journey back to Madison hit a snag. The A320 that we were supposed to be on broke and our flight got delayed, stranding us with an unexpected overnight layover in Dallas. And just when we finally got back on Tuesday and thought we were out of the woods, our FDM printer's hot end threw a tantrum. Swapping it out with a spare didn't do the trick, so we'll keep you updated on this. Looking ahead, we're also looking at other manufacturing options, like reaction injection molding, or maybe just going full send and buying a proper injection mold. That would be one of our stretch goals.
So there you go. That's one of their stretch goals. Okay, get my part to actually survive shipping is a stretch goal. Probably would not recommend that for sure. But again, part of your mitigation here. It's time for Mika mitigation. Make it a stronger plastic, injection molded, more repeatable. Maybe you have less voids in your print, so it's repeatable because it's injection molded. You have some sort of FEA, first article of FAI, first article of inspection, or quality inspection, right? And then before you ship it, check for delaminations, check for cracks, do some sort of dye check for a crack, like Dicom or something. Check for cracks, delaminations.
But at the end of the day, the sift bin is essentially a fancy bucket with a mesh.
Then do it again, ship it, etc., etc. Right, ship it somewhere, ship it across the country, then ship it back. Does it survive? What does it look like? Do the Dicom, etc. Check it.
In the middle. Plenty of companies can make these for us, and we are already in talks with them to ensure that what we deliver is not just functional, but durable. And yes, we are definitely going to improve our packaging, not just for the bin, but for the entire printer and its components. Another topic that has been on many of your minds.
There's under mitigation right there. Packing. Have better packing. Test it. Ship it. Do, a good size for how much you expect to ship for your customers. You're shipping overseas, do it. Ship it overseas, ship it back. What happens?
Is safety. Let's set the record straight. This is definitely not a living room printer. We still don't recommend setting it up in your bedroom or right next to your desk.
So here basically he's saying, oh, I had a disclaimer in some video, right, before, in the past. So that's what he's showing here.
Keep it away from your working and living spaces. However, most of the mess you've seen in the videos is largely due to the sift bin breaking, which, as I mentioned earlier, we're on track to fixing. The current sift bin, when it's not broken, is actually watertight. We've also found that our instructions were not as clear as they could be, which led to some confusion about the correct post-processing steps to minimize powder spill. Again, this is why we are user testing and will be improving. First, the powder.
Again, probably not a great idea to user test with public figures that will release a video on it, right?
Cake should never be lifted.
But, I mean, if he would have never shown this, we would have never seen this. So these are the types of things that a beta user would go through, right? Sorry, an alpha user. An alpha user will go through. So closed alpha, open alpha would go through this, right? And it's all, in this case, videoed for your knowledge, right? So this is kind of what's going to happen. But you don't want it to be how you see here, where it's in a beta user's hands and you still have these problems, right?
Out without the scoop in place. Also, whenever you open the lid after shaking the bin, make sure the dust.
So basically what he's talking about here is make sure that you have the...
So whenever you open the lid after shaking the bin, first, the powder cake should never be lifted out without the scoop in place.
So it said it should never be open, it never should be brought up without that scooper in place. But do you have an interlock to prevent that from happening? Clearly not. Joel here has lifted it up without the bin being there. So do you have, a little limit switch that allows you to lift it up with that being there, right?
Also, whenever you open the lid after shaking the bin, make sure the dust extractor is running to prevent dust plumes. When manually brushing the parts, installing the glass plate will help you achieve the necessary airflow. And about...
Okay, I haven't seen a single video using that. Was that in your procedure
Our dust extractor
to
glass
use
plate.
the glass plate as a something to keep it in there? It looks like it was. Looks like it was. So can you somehow help the user use it accurately? Because this is your internal video here that you've put out, but how do you help the user do it
Will
that
help
way?
you achieve the necessary airflow.
And also, this is kind of a risky part. If this is broken, is the printer down? Why are we using critical printer parts as accessories? Couldn't you just use a piece of cheap acrylic that costs $3-4 to ship?
And about our dust
Or a piece of polycarbonate that's pretty much indestructible, bulletproof almost. Can you use that instead of the glass that your laser shoots through, and that if it gets smudged, you have problems with it?
extractor, it might look dinky, but don't let its size fool you. It's got a HEPA filter and really strong fans that move a ton of air, which is why it's so frequently hot. For added safety,
Again, this is good.
we recommend wearing an N95 mask in case of accidental spills.
So again, this is talking about level 5 PPE.
Which is actually more than the recommendations from Evonik, the world's largest supplier of PA12 powder. You may have seen videos of people wearing full PPE suits with positive pressure respirator, but if you look closely, those are actually metal 3D printers, where the powder is actually toxic. An N95 respirator, when handling SLS nylon, is the industry standard.
There you go. Key. With regulations, industry standard. And I talked about that in the hardware procedure development. Is the product development, sorry, not procedure development, product development is industry standard. Okay, is your safety following industry standard? Here they're saying yes. Obviously, industry standard is bare minimum. You can exceed industry standard, which you said that, hey, this is the industry standard and over what our material safety data sheet says for the powder manufacturer. So we are exceeding what the powder manufacturer is asking, and we are sticking with industrial standards.
The printer is also equipped with a built-in carbon HEPA filter, and we will be conducting a full air.
That's good. That's why a lot of printers now are also doing the same thing.
Air quality analysis to make sure it
FDM printers
complies with the relevant standards before we ship you the machines.
Right. So also you ship that to the alpha, you ship that to the beta users in this case early, which like I think. But what type of things did they have to sign to do things like that, etc. Right?
Hey everyone, Henry here. You might have seen Scotty's video on his secondary channel, Stranger Parts, and here's our half of the story. Firstly, the issues that Scotty mentioned are real and we are actively working on them. We admit that a lot of these are our oversight and we take full responsibility. But we never asked for Scotty to hide any of the issues, nor did we ask any of the other creators to do so. We also never asked for the video to be delayed until after Kickstarter.
So again, a lot of this we are not going to get super in depth with, but basically, again, this is a beta user. And he's a YouTuber. His job is to do YouTube videos, not to help develop your product. If you want to have somebody help develop your product, make sure they know that from the get-go, right? And if you need to have something legally in place or pay them, then do that. But make sure that your what the expectations that person is going to receive. And you probably told Scotty, hey, we're going to ship you a beta, a unit that will be on Kickstarter, that will be representative of the Kickstarter unit that's going to hit the market, that's going to hit Kickstarter like right after. And then your Kickstarter is pushed for a year from now, pretty much. Your Kickstarter is delivering in 2025, right? So was the expectations aligned between you and these users, right? Or maybe just Scotty was the one of the 5 that was in the dark.
Kickstarter, contrary to what was claimed.
dates they've suggested are all either at the end of the Kickstarter or after the Kickstarter ends.
If you guys are unaware, you can cancel your Kickstarter pledge anytime you want. There's no point for us to trick you into pledging when you can just back out before the campaign ends.
Yes, there's a lot to gain from tricking people to back your product. Many Kickstarters have done that in the past. There's a lot to gain there. To just say, hey, my product, again, to overpromise and underdeliver, which is not what you want to do. You want to underpromise, overdeliver. So the people, same thing. Look at the No Man's Sky in this one, the No Man's Sky instance, right? Go ahead and look that up. Overpromising, underdelivering.
Releasing the video a week or two later might even give it more visibility since it won't be competing with all the other videos. Transparency is everything to us. We've shared detailed videos on not just how the printer works, but how we built it. Answer all your
I mean, this is great for content, right? The transparency, but this might be too much transparency, right? There's such thing as too much transparency, right? Transparency is good, and that's what a lot of people complain about on Kickstarter. Hey, where's the transparency? But at some point, it's like, hey, this thing is just not early enough to release. Then we can say, oh, hey, this is a beta, and this is how we do our Formica, things like that, right?
questions on Discord, offered print service to showcase our printer's part.
Again, this is good, but this part was great. This part is I agreed with, and actually I have an idea with. I'm working on some of printer technologies of my own, and this was actually one of the things I planned on doing, and so this is very good to see this. But doing this will help you. I mean, so you're basically getting paid to run your marathons, right? But you didn't see any of these issues while you ran these marathons.
Came to open source with a live demo, and
again, very good. A beta or open alpha, go and show people. Go to shows, show people. But 1 of 5 people had issues, right?
now made this video. The part about us asking for the printer back
Because, quote, we felt our hard work was not appreciated.
was taken out of context. And claiming that we want the printer back because the review is negative is just plain false. This message is where it all went downhill when he told us, I've already put a lot more time into this than I planned.
And clearly in this is right where the alignment seems to be missing, right? So it's like he expected to see a Kickstarter level product, right? And he's seen that with Carvera, the Carvera Air that he reviewed and things like that. And so he said, yes, this is going on Kickstarter and we are pretty close, right? And then he says, I appreciate that. Besides the auger jam, which is a system killing problem where the system will not print, and the dirty homing sensor from fixing the auger, again, a problem that would allow the printer to not print and not function its intended purpose. And it says, did you encounter any other critical system problems? It says, no, that has been the main one. But you have a main problem. That's the only problem you need. The system doesn't work. There's this one problem. It's like saying, my car's missing all the wheels. Or my car's, let's just say a bigger one, my car's missing an engine. And the manufacturer, like Ford or something, says, oh, well, everything else works though, so what's your problem? It's like, my problem is it doesn't drive. It's a car. It's intended to drive somewhere. And I can't drive somewhere without an engine. It just has wheels, right? So this doesn't hold, right?
And I have other projects.
And this has got it. Yes, I do agree that the printer's rough around the edges since it was built from scratch by just the 2 of us. Okay. Do you have any sort of manufacturing testing procedures? What's your manufacturing I talk about here? Right, so you go in here in these kind of betas, alphas. Do you have, some manufacturing control? Do you have a Q&A manufacturing testing before you ship it? Again, they said in Scotty's video that they tested it before they shipped it out. It seems that something happened, right?
projects I need to work.
So yeah, so I mentioned the manual step it took to, which he did, right? The manual step that it took to correct it for it, which he did show.
On. Take a moment and imagine if you were us. You spent the last 2.5 years working 70, 80-hour weeks with no weekends or holidays, waking up in the middle of the night from metal shavings, and now practically living in the lab, building everything from the lasers to the
Grin, I'm very thankful that this video exists, right? To show, hey, I have my machine in my house. Looks like this guy's basically got a bed inside the office, which in a lot of places is illegal. But let's gloss over that, because it's not zoned for residential. Anyways, could be his house. I'm not sure. Maybe it's a dorm room or something. Um, I love these guys' hustle, but again, you do not. Unfortunately, in this world, you do not get credit for 75% or was 80% of your machines working. You're shipping 200 machines, right? He's shipping, let's say for the Kickstarter, 200 machines. So let's say, 20% of them don't work. That's 40 machines don't work. That's a problem, right? So again, you don't get points for almost having a machine that almost works. That's basically how you could equate it to.
control boards.
And I know that's harsh, and I know that sucks, but unfortunately that's the reality of the hardware development game.
To the powder system, to the interface, and of course the entire slicer completely from scratch. All just trying to make a tightly integrated product and make SLS more accessible.
Again, it's a great idea. It's a great idea, but you need the execution. You need very high uptime. Beat the competition. So let's say that you do this $4,000 printer, but your uptime is, 60%. And then you have another printer, $40,000. Uptime is 98%. They're kicking your ass. I mean, you may have people buy it at a point and then just say, "Hey, this just," and then you'll destroy it for the rest of anybody else that wants to get into this market at this price point, and say, "Hey, this is just not accomplishable at this price point," right? And then people say, "Hey, there's no point of buying this. Just buy the more expensive one."
You then send the results of all this work to somebody free of charge, where you just sat in the corner for a week.
So again, and then he's talking about, so basically they're left on red and it sits on the shelf for a while.
And a half.
Again, what's the expectation? This is a beta user, right? This is a beta user and a YouTuber, so he's providing you a service of checking out the printer, giving you some feedback, and showing the world his process, right? So, did he do what he said he was going to do? Yes. Right? It looks to me like he did exactly what I would expect a YouTuber to do. And even more. He went more into detail and gave you guys more of the benefit of the doubt than I think a lot of YouTubers would. And just say, "Hey, this product sucks, don't buy it. Everybody don't buy it." And then push crap ton of ads on this video because he was the only one that had problems. But, I think that he did above and beyond, and I do agree with him that he does have an engineering background. It seems I'm not sure what it is, and I don't remember from his main channel, but yeah.
When issues arise, you immediately offer replacement parts. Then you get a message that sounds like they are fed up with it, and another one saying they don't have time to wait for the replacement part. Throughout this entire collaboration, we have been extremely proactive.
But again, with the replacement part, same thing with your final user, right? Your final user is not expecting to wait to get a replacement part to fix a printer that was supposed to work when it got there, right? So just be upfront with your, with your product development process. Like, hey, I did a prototype. This is my first. This is basically this is an open beta, which it should have an open alpha, which it should have been a closed alpha. Hey, this is a closed alpha, and you're talking to somebody that isn't a YouTuber, or somebody that is a YouTuber that has an NDA, right? And you say, okay, this is what we're trying to do. This. Let me know what you think. You've tested many printers. What are your thoughts on this? Okay, it's good. Let's go ahead and move this to an open alpha. Here's a couple changes. Here's the changes. Let me send it to you. All right, let me send you the parts, and let's up this to the open alpha. We're gonna remove the NDA. Let's go ahead and make a video, right? Or wait till the beta phase, right? The early part of the beta phase.
Offered help with setting up the printer, sent free additional printing materials, hopped on support calls at any time of the day, and reached out actively to see if there's anything we can do to help, just to be left on red. We asked for more time because we didn't want the auger issue, which was immediately fixed after installing the replacement part by the way, to take up almost half the video and be the only thing anybody ever talks about regarding the printer. So yeah, we treated Scotty in the same way that we treated anybody else. We are just two regular guys, and we've done the
Yes, but you treated Scotty like a closed alpha tester, not a open beta tester, right? That's the problem.
absolute best we can. Take from it what you will.
And there we have it, the things we are going to change to make Micron better and more user-friendly. We've added stretch goals to our Kickstarter, which is live right now, so check it out in the link below. And as always, don't forget to subscribe and hit that bell, join us on Discord, and if you have any questions, leave them in the comments.
Okay, so yeah, I mean that's basically what we're looking at. We can look at the comments, but I don't want to see all the videos on the side. So that's basically it for my comments on this reaction video. Again, very thankful for these guys for posting these videos. It just seems that maybe if they had, a product development process that when I finished developing mine, if they had something like this, a lot of these problems would have been avoided. Again, they have money issues. This PDP is not going to help you avoid money issues, but would have helped to avoid a lot of these heartaches and things that were hit at these different points. So, really good video. Any questions, don't hesitate to ask in the school group. I will see you guys on the next one. Take it easy. Peace.